Now here's an error message you might get from a compiler that can be a bit confusing at first, but it makes sense once you think about it. Now, that's usually how it is with compilers, right? So if I have a function and it takes a list of animals as argument, should I be able to pass it a list of cats? Well, that depends on the programming language, as it turns out. But let's think about it in the spirit of Barbara Liskow's substitution principle. If something has to be an animal, and it turns out it's actually a cat, that should be fine, almost by definition, right? Instances of the subclass are acceptable where the superclass is expected. That's what subclasses and superclasses are. Cat is a subclass of animal, so if there's a function that wants an animal, I can give it a cat, and that's fine. So back to the question. Should a list of cat be considered a subclass of a list of animal? You might think, yes, because the function should be fine, right? It's going to do stuff with its lists. It expects there to be animals, and there are. In fact, they're all cats, but who cares? What could go wrong? Well, I'll tell you what's going to go wrong. The function is going to insert a dog. As far as it knows, it's a list of animals. Dog is an animal, so that should work. But now if this list was passed by reference, that's the problem. The caller now has a dog in what they think is a list of cats. Surely that should be a type error. If not at compile time, then surely at runtime. Java, for example, says no, a list of cat is not a subclass of list of animal. Making such a call is a static type error. Is different for Java arrays, incidentally. The call is allowed, but it's a runtime error to insert a dog. So conceptually, lists in a pass by reference language that wants static type safety are what's called invariant to their element type. List of A has no subclass relationship with list of B, even if there is a relationship between A and B themselves. The list is passed by value, or let's say as a read-only iterator, then our original intuition was right. Read-only iterator of cat can indeed safely substitute for a read-only iterator of animal. That is called covariance. You inherit, no pun intended, the subclass relationship of your type variable. Now, interestingly, there are also natural examples of contravariant types. Consider function from animal to string and function from cat to string. Think about it. If you want a function from cat to string, it's actually fine if I give you a function from animal to string. It substitutes just fine. That's contravariance. It flips the subclass relation. Animal to string is a subclass of cat to string. So if you ever run into this compile error, you can remember this video and not be confused. And hopefully it helps you think about these concepts a little bit more clearly. It's also in this context that Java ends up with this seemingly silly question mark extends syntax, but I digress.